Renji here. I'm going to be making a bunch of videos with these to kind of go along with these Regents review sheets that we're passing out in class. The idea is I'm going to go through as many questions as I can. You, right, can look at the questions that you're having trouble with or you want to make sure you got correct or just review on, right? So if I'm taking a look at number one, I saw a lot of people in class, right? This wouldn't work for every question, right? But they just found the value of sine of 8 pi over 3 and they got an answer of, I think, like 0.867, right? Because I'm rounding it. And then they just went, well, I know 1/2 and -1/2 is not that number. If you put in the square root of 3 over 2, you actually get the same answer, right? Which is 0.87. The long way would be to show you with the unit circle and the fact that cosine are your x values and sine are your y values of the unit circle. But we'll get to that in one of those like little practice sheets later on this week or next week, right? So answer choice number 4, just by using your calculator. Number 2, I look at this one, right, and I right off the bat see my answer choices, right, as factors. So that means, right, whenever I see something like this, I want to simplify this as best as I can before I try to like figure out which one's equivalent, right? So for this one, right, I'm going to start by x minus 2 squared. So I'm going to multiply, right, x minus 2 times x minus 2 plus what? 27 times x minus 2 minus 90, right? So that's my hint, and for most questions, I'm going to try to give you a little hint, pause, right, and then come back with the answer afterwards. So, right, if I think about this, right, I'm just multiplying my first two terms together, right? That's going to give me what? If I do FOIL, x squared minus 4x, whoops, actually minus 2x because I skipped a step, right? Minus 2x minus my inners, which is another minus 2x. Minus 2 times minus 2 is positive 4. Here I'm just distributing, so I'm going to say 27. I'm going to say plus 27x minus 54 minus 90. Now I'm just combining like terms, the x squared, there's nothing to combine it with. Negative 2 minus negative 2 gives me negative 4 plus 27. That's going to be a positive 23x. And then positive 4 minus 54 gives me negative 50. Negative 50 minus 90 gives me minus 140. And then from here, right, I'm just going to kind of see, right, which numbers multiply up to 100 or negative 140, but add up to positive 23. I have help because all my answers are already like here, right? All my factors are already here. If I look at number 2, right, indeed, right, 28 times negative 5 gives me negative 140, and then 28 minus 5 gives me positive 23. So my two factors, right, are x plus 28 and x minus 5. Jumping down to number 3, right, these are questions where, and I feel like there's one of these on every Regents, is you have a function f of x equals 2x plus 5 over 2, and then also g of x equals 3 over x. We could set these equal to each other, right, and solve for x, but you can also use your calculator, right? So if I go into my calculator and I plot 2x plus, make it into a fraction, 5 over 2, and then on the bottom, I'm just making this into a fraction, and it's going to be 3 over x. I graph it. I get something that kind of looks like this, right, where my first function, right, that's linear, so it's just basically a line kind of going straight through my graph, and then this one, right, is a nonlinear function, so it's going to look kind of like this, right, with the two curves. The reason it's got the two curves is because the asymptote, right, is at 0 because I can't put a value of 0 underneath here, right, because it's going to be undefined. And then, right, I can use my calculator to find the intersect function, right? So I would go to second up at the top, calc, go to number 5, that's intersect, right? And if I click on my first line, right, which might be the blue one, or in this case it's the red one, click on my red line, click on my blue line, guess the intersection point. The intersection point right here is -2, -1.5, right? And if I do it again, right, I'm going to say go to second calc, intersect, except this time I'm going on my red line and then I'm going on the blue line, right? That's in quadrant 1. Might have to like move the cursor around a little bit, but it gets there. Press enter again. This time it's giving me this intersection point as 0.75 and 4. I have a bunch of there's a bunch of answers, right, that have these numbers here. You just have to know, right, the solutions are going to be your x values. So kind of right off the bat, you can know that these are wrong because they're giving you y values. This they're giving you a coordinate point, and this they're giving you the two values, but it's as a coordinate point, right? So you want to know x equals 0.75, x equals -2. Answer choice number 2. Whew, it's a long one. But when in doubt, go into your calculator, graph them, and try to find intersection points if it's looking for things like this, like solutions. Scrolling down to number 4, right? The second I see something like this and I see like the little plus or minus i's, I know I want to do the quadratic formula. Before I do the quadratic formula, I need to get, right, one side of my equation equal to 0. So that means I'm going to add 10 to both sides, right? Once I add 10 to both sides, what am I left with? I'm left with 4x squared minus 7x minus 2 equals 0, right? And I kind of love when I see you guys, right, now say, well, I know for quadratic formula I need an A, a B, and a C. My A value is 4. My B value is -7. And whoops, that's actually a +8. So that was the first mistake you saw, right? And that's a positive. Ooh, +8. Oh God, we're losing it. +8. Cool, right? And then from here, right, my little hint is go into the quadratic formula. I'm not going to rewrite the quadratic formula because it's going to kill me if I do. But the quadratic formula is -b, right? So what's -b? Negative, and I can't stress enough, right, to put, anytime you substitute this stuff in, put the parentheses around it. -b plus or minus b squared, same thing, parentheses. If you don't put parentheses on it, it's going to come out as -49, and you're messed up, right? Minus what? 4 times a times c, the square root of that all over what? 2a, which is 2 over 4, right? Inside here, right, if I put what's underneath my square root, right, just like this in my calculator with all of the parentheses, right, I will get the right answer every single time. So I'm going to say negative parentheses, -7, close parentheses, squared, whoops, minus 4 in parentheses, 4 in another parentheses, 8, I get -79, right? So that becomes -79. Everything else, so the square root, right, is these two negatives become positive. All over what? 8. I start to look at my answer choices. Well, really, there's only one choice that looks good. This would be spitting out an imaginary number, right? So really, it just stays the radical 79 with the I at the end. 7 over 8 plus or minus radical 79 over 8i. Answer choice number 3. Good to go. Number 5, right? is x minus 5 a factor of this big function over here, right? They're not giving you any actual like numbers, right? Because they just want you to know one thing, right? And you're always going to get a question like this too. The remainder theorem, right? The remainder theorem says if there's a factor, right, you're going to have a remainder of 0, right? So here, right, they're telling me my factor is x minus 5, but that's not my actual root, right? Because I would actually want to say x minus 5 equals 0, because that's how I'm going to get my actual 0. So one of my zeros is x equals positive 5. This is what x values are always inputs. So I know if I input this, right, into my function, I'm going to get an output, right, of 0. So input of 5 gives me an output of 0. Answer choice number 2. And we're good to go. And this is, right, I'm going to say it again, the remainder theorem, right? So take any factor. You want to find the 0, right, of the factor, which is you're setting it equal to 0. So you're kind of switching the sign. If you had to plug it into one with actual numbers, you would get, right, if it was a factor, you get a 0, right, as an answer. If it was anything else, like not a factor, you would not get 0 because you would have a remainder. Cool. Number 6, right, this should hopefully be a gimme if you have something like this. Let me keep it up, right? For all positive values of x, which expression is equivalent to the square root of x times, this is the 4th root of x to the power of 11. Fractional exponents, right? I know here's square root of x, so I'm going to rewrite it as a fraction. Square root of x, right, has a power of 1, right, and a root of 2. Power always goes on the top, root goes on the bottom. So that means if I'm turning this one into a fraction, well, what's my power? My power is 11. My root is 4, right? And then, right, I know if I'm multiplying same bases, what am I doing? I'm adding my exponents, right? So if I come over here, right, and this is where, right, you got to be careful. In your calculator, you can literally put fraction 1 over 2. And since I'm multiplying exponents, fraction 11 over 4, right? I'm adding them together just like this. You would get something, depending on how your calculator is set up, it might say 3.25, right? Because it's a decimal. But you go to your math function. First button is change it into a fraction. Your fraction, right? 3.25 equals 13 over 4 as a fraction. Right? What's my answer? Answer choice number 2. Hopefully this first video helps you out. Keep it rolling.